Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. For the prop beam shown subjected to the loading ML, compute the external support reactions. Evaluate the above requirements when ML is 120 kilonewton meter, A is 6 meters, and B is 4 meters. So that means L is 10 meters. So due to this loading, let's have the deflected shape. And let's call this the moment at A. Let's just call it M and assume clockwise. Then AY, then at B we have RB only. Due to this loading, the beam will deflect, and imagine the support B is removed, will deflect that way. This part of the deflection is straight because the loading ML is just up to here. So therefore, the deflection is, let's call this delta 1, and this part here is theta 1, the slope at this end where ML acts theta 1, then therefore tangent theta 1 is just theta 1. Remember the principle. So opposite over B, or delta 2 over B. Therefore, um, because tangent theta 1 is just theta 1, this deflection 2 is equal to B times theta 1. So remember that the formula delta is, or EI delta is moment at the wall, L squared divided by N plus 2. So in this case, moment at the wall due to the load is ML. The distance is A, so A squared divided by 0 degree plus 2. So delta 1 is ML A squared over 2 EI. While delta 2, B theta 1 is moment at the wall ML, L, which is A, divided by EI. So delta B due to the load is delta 1 plus delta 2. Delta 1 is MLA square divided by 2EI, while delta 2 is B times theta 1 MLA over EI. So EI delta B due to the load is equal to, factoring out ML. So let's simplify first. MLA square over 2 B times MLA. Factoring out MLA over 2. So EI delta B due to the load is MLA over 2 quantity A plus 2B. Then, because due to reaction at B, it will deflect upward. And the formula is reaction, or P, L cube over 3EI. In this case, RB, L cube over 3EI. So EI delta B due to the reaction is RB, the force, L cube over 3. Equating, they are equal numerically, supposedly, because there's no support settlements at B, support movement. So RB L cube over 3 equals MLA over 2 quantity A plus 2B. So R sub B is 3 ML. A is L minus B, then this is L plus B. So over 2 L cube. A plus 2B is A plus B plus B, and A plus B is L. Then there is another B, so L plus B. Multiplying these two, RB therefore is 3ML over 2L cubed quantity L square minus B square. So 3 ml over 2L cube quantity L square minus B square. So that's the compact form of the reaction at B. Then AY is just equal to RB, but AY is downward. So AY is 3 ml over 2 times L cube quantity L square minus B square. And it is downward. So summation moment about A equals 0. Let's consider this M. Let's assume M is clockwise. So M plus ML equals RB times L. So M plus ML equals RB times L. Summing up moments about A. Substitute the value of RB. So M is RBL minus ML. M is also MA. RBL minus ML. Substitute the value of RB, which is 3 ml over 2L cube quantity L square minus B square times L minus ML. So we cancel L here, 1L. So MA equals 3 ml over 2L square quantity L square minus B square, then minus ML. Factoring out ML, so MA equals ML over 2L square quantity 3L square minus 3B square minus 2L square. So we distribute, factoring out ML square over 2L square rather. So we distribute 3L square minus 3B square. Then this is supposed to be 1 times 2L square, so minus 2L square. So 3L square minus 2L square is L square, therefore MA is ML over 2L square quantity L square minus 3B square. And this is the compact form of MA. So that's why we write this as our answer for MA. Now let's evaluate AY. So AY is 3 times 120 over 2 times 10 cube times the quantity 10 square minus 4 square. B is 4. So AY is equal to 15.12 kilonewtons downward. So that means RB is also 15.12 kilonewtons upward. And MA is, substitute here, MA is 120 over 2 times 10 square, quantity 10 square minus 3 times 4 square. So solving for MA, computing for MA is 31.2 kilonewton meter. Because it is positive, so our assumption is correct. So it is clockwise. So that's it for this problem. I hope that you were able to follow and understand the explanations and the solutions.